right, so switching to linear transformations, which is notes 3-12. Okay, you can do a lot of this in the calculator, so I'm going to show you different ways. We're going to graph the parent function f of x equals x. Now, a parent function just means the generic to it. So, like, I can change this function if I put numbers in front of it, but right now it's just plain Jane, simple x. Now, function notation is something I particularly don't care for, so just remember, when you have f of x equals x, this is just the exact same thing as y equals x. Now, if we're going to graph this, there's two ways you can do it. You can do it by hand, which would mean you need to tell me what m is and what b is, which is really easy because b is 0, there's nothing there, and m would be 1 over 1. And then I could graph this. But if you don't want to have to recall that information, you could just go to y equals and put in x. You could graph it to see what it looks like. And then you could go to the table, so second graph, and get a bunch of points. Now, I'm going to just go ahead and use m and b. So I know I'm starting at 0, and I must rise 1 and go right 1. So up 1, right 1, up 1, right 1. I'm going to keep repeating until I can't get any more points. Then I'm going to go back to the original and do the opposite, down 1, left 1. Now I'm going to go ahead and connect my dots to make my line, if I could draw it straight. Putting arrows on there because those arrows tell you it goes forever. And then just some old review from Unit 2, Domain and Range. Remember that domain is just the x values, and x goes left to right. Range is just the y values, and it goes down to up. So what I'm going to do is I'm going to scan this graph to the left and see how far left it's going to go, which it just keeps going and going. And then I'm going to scan this graph to the right and see how far right it goes, and it just keeps going and going. So since this goes forever, we write all real numbers, or you can write the word out if you don't like the symbol. Now for y, I'm going to scan down and see how low it's going to go, and this arrow tells me it keeps going down forever. Then I'm going to scan up and see how high it goes, and it's going to keep going up forever. So if it's going up and down forever, again, it's all real numbers. Now, what we're going to do, there's going to be 3 different types of changes. We're going to use our calculator to graph each line below and compare it to the parent function. Now remember, the parent function is just this graph right here. Okay, first thing I'm going to do is do the plugged in form. This is the function notation form. We're going to convert it to y equals because y equals is way easier to work with. They gave us that f of x equals x. So anytime you see f of x, replace it with x. Now, we're going to convert g of x to y. So we're going to put y equals. Instead of f of x, we're going to put x plus 3 because f of x equals x. And then we're going to come down here. H of x is going to be y equals. Instead of f of x, we're going to put x minus 7. So now what we're going to do is we're going to go back to the calculator. We're going to leave x in y1. We're not taking that out at all because that's what we're comparing it to. You always have to compare to the parent. Then I'm going to move down to y2 and make this x plus 3, and y3 I'm going to make x minus 7. Once I have all of them, I just want to see what the change is. So before I press graph, I want you to notice that x is going to be in blue because that's the color on the side. X plus 3 will be in red, and x minus 7 will be in black. We're going to hit graph. I've already got x graphed. There went x plus 3, and there's x minus 7. So if you look at them, this red line shifted up. It still has the same slope. It's going at the same angle, but it shifts up, and it went up 3 spots if you count those tick marks. Now x minus 7, it shifted down, and if you count the tick marks, it shifts down 7. Okay, if you notice, I did not put a negative here because it just went down, took care of the negative. Now it says conclusion. Conclusion is, what did you learn from this? Okay, and what I learned from this is that a plus sign shifts up and a minus sign shifts down. Now, when you're doing your worksheet, you're going to have to be specific, like how I was here, and tell me how many up and how many down. Moving to the second change, again, we're going to use that calculator, but first thing I got to do is convert this. And remember, the parent function is just f of x equals x. So anytime you see f of x, replace it with x. G of x is going to become y equals, we're going to keep the 2, but instead of f of x, I make it an x. H of x is going to become y equals, and I keep the 1/5, but instead of f of x, I replace it with x. So now this time I'm going to go into y equals. I'm going to leave y1 alone. I'm only going to clear out y2 and y3. In y2, I'm going to put 2x. And in y3, I'm going to put 1/5 x. So x goes in the first, and then 2 and 1/5 in the next 2. And I'm going to hit graph. There's my x, because the blue line's the original. There's the red line, which is 2x. And there's the black line, which is 1/5 x. Now this time, if you notice, all of the y-intercepts are the same, but I'm wanting to know how they changed. So for this graph, the 2, if you were to look and compare the blue line to the red line, if you were to put a person on it and you were walking up this hill is way steeper. So this number made it steeper, and it's by a factor of 2, but I'll just let you put steeper by 2. Now 1/5, this hill would be way easier to walk. It wouldn't take as much effort to walk. So this is less steep. Oh, spelt that wrong. There we go, less steep, and it's by a factor of 1/5. Okay, so for our conclusion, and this is the weird, tricky part, numbers greater than 1 make lines steeper. Numbers less than 1 make lines less steep. Okay, if the number is 1, don't do anything with it. 1 doesn't change anything because we originally start with a 1. Okay, now flipping to the back so you can see the other changes. There's one more type of change, and then we're just going to do some predictions. Okay, use your calculator to graph each line below and compare it to the parent function. Remember, parent function is just f of x equals x. The first thing that we're going to do is we're going to convert to the y equals. So I'm going to put y equals. I'm going to keep the negative. I'm going to keep the 5, but f of x becomes x. For the next one, I'm going to keep the y equals. I'm going to keep the negative. I'm going to keep the 1/4, and the f of x becomes x. So now when you're doing this one, you should already see something that you noticed before. Okay. We've already worked with these whole numbers and fractions, but we haven't seen a negative sign. So what we are going to do is I'm going to go back to y equals, and I'm going to leave x alone, but I'm going to plug in negative 5x and negative 1/4 x, and then I'm going to graph. There is my x, the original line. That is my 5x, and that is my 1/4 x. Okay, now that I see this, I can see that the line was going uphill originally, but now they're going downhill. Okay, so the thing that is important and different is that the negative sign flips this. And then the 5, that line, you'd practically be running downhill, so it is steeper. Yes, ma'am? No, mine shut off. That went off. Okay, so this became steeper, and it became steeper by a factor of 5. Okay, for the other one, I have negative, and the negative flips it. But the 1/4, this became a shallow line. It's easier to walk, so this is less steep, and it's by a factor of 1/4. That looks like a 9. 4. Okay, so my conclusion, I already knew steeper and less steep. I've worked with that on change number 2. So the conclusion is a negative. A negative is what is important, and it makes the graph flip over the x-axis. Okay, now moving on. When you're making your predictions, you're going to look at everything individually. The negative is not going to be connected to the 5. You're going to look at the negative as a negative. You're going to look at the 5 as a 5, and you're going to look at the plus or minus as a plus or minus. Now, you can use the calculator if you want to see the change, or you can use the conclusions we made on the notes. Okay, the first thing I'm going to do is convert these to y equals. This is y equals, I keep 2, f of x becomes x, and then minus 3. We're looking at the numbers. Okay, a 2, if you flip back to change number 2, is a number greater than 1. And numbers greater than 1 make the line steeper. So this would be steeper by 2. And then a minus, so flipping back over here to change number 1, a minus shifts it down. So we're going to put shifts down by 3. Okay, for h of x, I'm going to convert. H of x becomes y equals. I keep the negative. F of x becomes x, and then minus 3 again. I'm looking at the negative and the minus 3. Those are my two changes. So I learned that a negative in change 3 flips over x-axis. And I know that a minus 3, because I just had one of those, shifts down 3. Okay, for the next one, k of x, I can put y equals. This becomes 1/2. Instead of f of x, I put x plus 1. I'm looking at the fraction and the plus 1. The fraction, this is less than 1, so if you flip over to change 2, a number less than 1 makes the line less steep by 1/2. And I shift up 1 because of the plus 1. Okay, I'm going to pause for a minute and I'll finish in just a second. Okay, so finishing up these last two examples really quick, we're going to write an equation for these. So we're going backwards. Instead of telling me how it changed, you're going to come back to the equation. So if you shift up 2, we learn that up 2 means we have to add. And if it's flipped over the x-axis, a flip over the x-axis has to be a negative. That's not a minus sign, this is a negative. So we're going to start with y equals, and I know it has to be negative, and I keep x because I didn't get any steeper or less steep. And then I went up 2, so plus 2. Now, if you want to take it a step further and get all the way back to function notation, you can pick any letter you want to for the y. So I'm going to just do g of x equals. I keep everything but the x, so I have negative, and this becomes f of x plus 2. I would accept either of these. These are okay. Now, less steep by 1/4. That means you're going to have 1/4 in front of x, because less steep is a number in front of x. Shifted down 3 means we are minus, and this time this is a minus, not a negative, 3. Okay, so I'm going to start with y equals, and it goes 1/4 x minus 3. And if I were to make this back to function notation, I'm just going to stick with g of x. And it equals 1/4. We keep everything but the x. The x becomes f of x minus 3. All right, so if you have any questions, please make sure that you're asking.